Alright, so now we're going to be talking about section 3.3, the cosine law. So let's just review what we talked about in the previous lessons. When can we use the basic trigonometric ratios, sine, cos, and tan, from SOHCAHTOA? Well, we can use them only when you have a right triangle. What about the sine law? When can we use the sine law? Well, the sine law can be used when you have an angle and its opposite side plus one other piece of info. So if we look at this triangle here, if we had that this angle was 120 degrees and this side was 10 and this side over here was 8 and we needed to find this angle, then we would use the sine law. Alright, now we come to what the lesson is about today. When can we use cosine law? Well, we can use cosine law when we have all three sides, or we have two sides and the angle between them, and that situation is called side angle side, or SAS. Let's look at an example of when we would use cosine law. So in this triangle right here, if we had all three sides, this is 4, this is 6, and this is 8, and we were looking for this angle right here, then we would use cosine law. Or if we had an SAS situation, side angle side, where this was 4, this was 8, and we knew the angle in between the two sides was 40 degrees, okay, then we would have the side angle side situation, and we would be able to find this missing side right there. So what exactly is the formula for the cosine law? Well, given triangle ABC, remember that the sides are characterized by little letters and the angles are all capital letters. Okay? So if we're looking for side A, given that we have side C, side B, and angle A, the formula would be A squared, the unknown side, would equal B squared plus C squared minus 2BC cos of angle A. Now if we were looking for side B, given that we had side C, side A, and angle B, the formula would then be B squared equals A squared plus C squared, the other two sides, minus 2AC cos of angle B, the angle that we know now. And lastly, if we were looking for side C, given that we had angle C and A and B, then the formula would look like this. Very similar to these other formulas, starting off with the side that we don't know. So it would be C squared equals A squared plus B squared minus 2AB cos of angle C. So that's if you have two sides and an angle and you're trying to find an unknown side. But what if we're trying to find an unknown angle, such as C, and we have side A, side B, and side C? Well, then what you would have to do is you'd have to manipulate this formula, do some algebra, to get that cos of angle C is C squared minus A squared minus B squared. So what I've done is I've brought these two over and then divided by negative 2AB to get that on the bottom. Okay? And you would do the same if you wanted to find the angle in these two scenarios as well. So just to recap, these three formulas right here, which are the cosine law, you would use these when you are given two sides and the angle between the two sides, and you need to find the third side. The manipulated form of the formula, you have to move the unknown sides over and divide by the 2AB. That type of formula is for finding the angle. Okay, we'll look at some examples in a minute. Okay, so let's look at this example. Calculate the length of AC, this line right here, which is represented by the letter B. Okay, and that's it. That's all it tells us. So, what do we have? We have a side, the angle in between, and another side. That's an SAS situation. So what are we given? We're given a side, an angle, and another side. Which form of the cosine law should we use? Well, we're trying to find B, so it's going to be B squared equals A squared plus C squared minus 2AC cos of angle B. So now we're going to just substitute the known values from this triangle into this formula and see what we get. So B squared equals, what's little a? Little a is the side that's across from angle A. So that's 6 squared plus 4 squared minus 2 times 6 times 4 cos of angle B, and angle B we see up here is 60 degrees. So cos 60. So when you put this on your calculator, you need to remember order of operations. You can't just go 6 squared plus 4 squared minus 2 times 6 times 4 times cos 60. You need to do this part first, write it down, then do this part, write it down, and then subtract those two answers. So go ahead and do that now. Pause the video, and you should have gotten that B squared equals 28. Now remember, how do we get rid of something that's squared? We have to do the opposite, and the opposite of a squared is square root. So that cancels out, so B equals the square root of 28, which equals 5.3. Let's look at the next example. Calculate the measure of angle A in the triangle. So what do we have? We have this side, and this side. Little a, little b, and little c. So what are we given? We're given three sides. S, S, S. Okay? Which form of the cosine law should we use? Well, let's write the cosine law down. Okay? So we're trying to find angle A. So we're going to start off with a squared equals b squared plus c squared minus 2bc cos A. But what we're really trying to find is the a here. So we need to manipulate this formula. Okay, so let's see how we would do that. First, we need to bring what's being added over to the other side. So we get a squared minus b squared minus c squared equals negative 2bc cos A. And now to get the cos A by itself, we need to divide both sides by negative 2bc. So that cancels out there. And we're left with equals cos A. Now we can substitute in the values from the triangle above. So cos A equals little a squared, which little a above is directly across from angle A, so it's going to be 8 squared minus little b, 7 squared, minus 5 squared over negative 2 bc, which is 7 times 5. And if you do that on your calculator, you'll end up with negative 10 over negative 70, or 0.1428. So we're not quite done yet. We figured out that cos of A equals 0.1428 dot dot dot. But we need to find angle A. So we need to get rid of this cos. Remember from the last section, to get rid of cosine or tan, we do what's called the inverse cos. So cos -1 of 0.1428, and you end up with 81.8 degrees. I just rounded to the nearest tenth, and that's that.